Good afternoon, everyone. Welcome to today's webinar on how to detect and eliminate root cause in quality process. We are so glad you could join us. I'm Santoshi, and today our team is going to showcase on how live QC tools can help transform the way you solve quality challenges. Since 1993, EGS has been at the forefront of delivering cutting-edge engineering solutions to manufacturing industries across India and beyond. Over the last 3 decades, it just has partnered with organizations in diverse sectors. What set EGS apart is not just a technical expertise, but also the blend of conventional wisdom with lateral thinking. A team of specialists backed by years of product development experience has consistently delivered value to both large enterprises and small engineering firms alike. From mission critical programs to challenging the frontiers of new technologies, EGS India has always stood as a trusted partner in innovation and engineering excellence. We are proud of this journey of more than 30 years and remain committed to enabling a customer to achieve fast product development, enhanced reliability, and global competitiveness. Having rich experience, Live QC tool software has been developed by a team of experts with decades of experience in implementing best in class process worldwide. Our vision, engineering development through effective partnership. Our mission is simple but yet powerful to provide best in class tools and technologies for better tomorrow. Our values are built on ethics, responsible corporate citizenship, and continuous improvement. At the core of live QC tools is a belief that incremental improvements in well-defined process lead to a remarkable outcome. Live QC is designed to be simple, easy to use, and affordable without compromising on quality. A platform empowers organization to achieve the three pillars of operational excellence: cost, time, and quality, while consistently delivering customer satisfaction. And this is exactly what LiveQC tools help you achieve. With a platform, you can define process, manage records, assign and track tasks, plan better, and finally, visualize with charts by connecting data from multiple sources using drill downs for continuous improvement. This end-to-end workflow ensures that you're not just reacting to quality issue, but proactively preventing them while keeping your operation efficient and transparent. When people hear the word quality, many still think it means slowing down production, inspection, fault finding, fixing problem, or just doing paperwork. But that's a misconception. True quality is not about finding faults after they occur. It's about preventing them in the first place. Quality is a mindset, a failure, and a process oriented approach. It's built in, not inspected in. It's about risk reduction, efficiency, continuous improvement, and above all, creating value for the customer. This brings us to today's focus: root cause analysis. Root cause analysis is a systematic method to identify the real reason behind problem, not just the symptom. It's been around more than 8 decades, since the 1940s, originally used in manufacturing to identify equipment failures, and has since evolved across industries. Root cause analysis helps manufacturer improve efficiency, reduce cost, enhance product quality, and even improve workplace safety. Many of you may already be familiar with tools like Fishbone Diagram, AD, Pareto Chart, Scatter Diagram, Control Chart, and even other QZ tools. These have been extremely valuable, but as manufacturing grow more complex, manual root cause analysis often falls short. Coming to today's agenda, many root cause analysis can be slow, resource heavy, error prone, and difficult to scale. Imagine engineer running between machines with USB drives, analyzing data in spreadsheet, trying to beat production downtime. That's completely costly and inefficient. With live QC tools, root cause analysis becomes smarter and faster. Instead of firefighting problems, you can prevent them, enhance your efficiency, and create a culture of continuous improvement. So today we'll explore how to detect and eliminate root cause in quality process. By the end of this session, you will see how can you solve your toughest quality problem faster, smarter, and at scale. So now I'll hand over the session to our speaker, Mr. Tamalvanan from our Live QC team to lead us through an exciting session on how to detect and eliminate root cause in quality process with Live QC tools.
Thank you Santoshni for an intro. In this session, I am going to discuss about how to detect and eliminate root cause in quality process. Myself Tamilvanan, an application engineer from Live QC Tools. In this session, we are going to discuss about root cause analysis, potential causes of risk and hidden factory cause. Before getting into this session, let's see what is quality. Quality is known for conformance to the standard or specification, fit for purpose, meeting the customer requirement, value for money, as well as free of defects. The culture of manufacturing quality is to avoid non-conformance, a situation where a product, process, or service fails to meet the customer requirement or specified standard. It could be happen due to human error, equipment failure, process deviation, and also material defects. Eliminate the cause of an existing non-conformance could be a deductive, whereas eliminating the cause of an preventive potential non-conformance before it happens could be a preventive, whereas continuous improvement is an ongoing effort to enhance the process, product, or service by making incremental improvements over a time period. When things seems to be working well also, we should able to improve in efficiency, quality and customer satisfaction. Concepts like Lean Six Sigma, PDCA and DMAIC were followed in continuous improvement. Meanwhile, root cause analysis, YY analysis and fishbone are used as analyzing methods. In our day-to-day life, quality department plays a critical role in ensuring that product meets the standards, compiling with regulations and satisfy the customers by taking responsibilities, leaderships, continuous improvements, employee engagement and by data-driven decision makings with risk mitigations. In this session, we are going to brief about root cause methods to improve the process. I hope we have professionals here from various domains within the manufacturing and engineering industries. Let us consider a scenario for a failure cases and discuss about the root cause analysis. Where root cause analysis is a structured method of solving the problem by identifying the potential causes of a failure or non-conformance and not just its symptoms. Whenever a problem has been raised, the common questions that we are asked were what exactly happened, why did it happen, where did it occur, what did happen, who was involved or affected, and how it is happened, else how many were affected. The informations can be gathered from various sources like inspection records, work logs between the shifts, feedback of customers, and maintenance history checklist. Once the information has been gathered, we could be able to solve the issues. Whenever a problem were raised, we could be recommended to solve the issues by manual process using plain papers, whiteboards where multiple team can work on an individual. These problems are recorded using the spreadsheets and presentation tools which allow us to display the issues and create quality alerts to prevent them at an earlier stage. Then a partial tools like ERP and PLM are used to store the problem informations for the future use. Ishikawa diagram, most commonly known as fishbone diagram or cause and effect diagram. It is an effective way to organize and display the theories about all the root causes to an observed symptoms. The tool has three prominent basic features. It is a visual representation of factors that might contribute to an observed effect that is being examined. The interrelationships among the possible factors is clearly shown and one causal factor may occur in several places. For example, temperature affects both moisture content and physical dimensions, then temperature could appear in both places. The interrelationships are generally qualitative and hypothetical. All possible sources of causes need to be considered in terms of man, machine, material, method, measurement, and environment. Here comes tools like live QC tools, where it is used to improve the brainstorming sessions and make decisions more effective, since it promotes team collaboration, sharing of knowledge by solving issues, and achieving the target goals by improving the processes. Not only we are creating the fishbone structure, we also help to find the actual potential causes that leads to failure. Whether it may be a lack of training, lack of involvement in terms of man, whereas lack of mission maintenance, lack of involvement in terms of mission, and skipping of incoming inspections or receiving inspections, and sometimes material mix up in terms of material, and lack of quality alert displays and skill metric information regarding the quality persons as well as operators, and mishandling of materials in terms of methods, and inadequate training to the professionals, and wrong measurement method in terms of measurements. And we could also able to collect the 5S maintenance checklist and also follow the 3C concepts, or in terms of environments may lead to failure. Statistical process control can be described as a feedback system. The process control system is an integral part of an overall business management system. The goal of the process control system is to make prevent predictions about the current and future state of process. A process is said to be an operating in statistical control when the only source of variation are common causes. The strategy of prevention is proactive quality management approach focused on avoiding defects and problems before they occur rather than detecting and correcting them after the fact. It is easily captured in a slogans like do it right the first time. Variations in the process may occur due to common cause variation and special cause variation. Gradual wear and tear of the process may be leads to common cause variation, whereas unusual causes like accidents, breakdowns, and failures leads to be an special cause variation. If only common cause of variation occurs, the output of the process forms a distribution that is stable over a time period. Whereas in special cause variation, the process output is not stable over a time period and it is unpredictable. We could be able to create a process trend whether it is within the limit of upper specification limit whereas lower specification limit. We could be able to calculate the CP and CPK value of a process by providing the upper specification limit as well as lower specification limit. Once the process has been captured, we could be able to detect the analysis using the Pareto analysis. A Pareto analysis is a ranked comparison of factors related to quality problem. Pareto analysis and tables are presentation techniques used to show the facts and separate the vital few from useful many. A non-conforming product is one that fails to meet or more specification, and a non-conformity is a specified type of failure. Pareto analysis is a bar graph with frequency on left side of y-axis and percentage on the right side of the y-axis, and contributing factors are arranged on the descending order by frequency on the x range. Once the analysis has been done with the Pareto analysis, we would be able to take a corrective action, and a scatter diagram is a graphical representation of relationship between the two variables. In quality improvement, scatter diagram is usually used to test cause-effect relationship in a diagnostic journey. Discovering the cause and effect relationship is a key to effective problem solving. Cause and effect relationship among always shows variation. It is easier to see the relationship in a scatter diagram than in simple table of numbers. As one variable increases, the other variable also increases in the positive correlationship, as well as one variable increases, the other variable decreases in the negative correlation, whereas no consistent pattern will form in no correlations. And overcoming with this, we could be able to solve the issues whenever it raises with a structured approach called AD problem solving. AD is a structured problem solving approach used to identify, correct, and prevent the recurring issues. AD approach aims to identify and eliminate the root cause of the problem, implement team corrective actions, prevent recurring of issues, and improve overall product and process quality. It has a structure from D1 to D8, whereas D1 terms to team formation, who needs to be involved in it, and the primary problem solver will be taking care of the issues, whereas in D2 state the problem will be described what exactly is wrong, and here we could be able to answer what, where, when, and how many were affected. In the discipline 3, we could be able to determine the containment action. An action against the complaint immediately within 24 hours without affecting the regular workflow is a containment action, and we could be able to solve the issue and find the root causes in the D4 by carrying the brainstorming sessions with stockholders over different methods like 5W2H and YY analysis, and also by using the fishbone diagram. And we could be able to address the issues in the D5, where we could be able to create a permanent corrective action, addressing the actual root cause of the problem and finding the solutions and validate the process and corrective measures. And in the D6, we could be able to validate the corrective actions using the tools like scatter diagrams. Once the solutions were found, the problem, the corrective action is validated and how effective it is, and we could be able to take a preventive of reoccurrence like updating SOPs, documenting and displaying of quality alert in D7 to take a preventive action of reoccurrence. And in D8 we could be able to recognize the team, acknowledging the success and encouraging the team to the coordinations. When we are overcoming with this type of activities, we could be able to find the hidden factory cost more valuable. We could be avoid the internal failures such as process delay, workflow, scrap and validations, and loss of qualities. Whereas external failures like customer complaints, warranty claims, loss of customers, sort and rework of customer places, and low quality scores, we could be overcome with preventive methods like providing trainings and maintenance and scheduling and planning. And the appraisal costs like inspection costs, calibrations and audits were plays a major role in cost of good quality. Here comes live QC tools, where we could be able to collect data collections, process mapping, defect tracking, sharing of knowledges, and addressing the issues with non-conformance, as well as corrective action and preventive action reports, and root cause analysis with defined templates. And we could be able to address the issues whenever a complaint raised with an structured approach of 8D reports, and carrying of audit managements, record managements, and predefined templates, whereas statistical process control charts were used to analyze analysis of process and conducting of MSAs, control plans, FMEAs, and calibration maintenance. And we could be able to configure the templates as per the requirements. Here come live QC tools were used to reduce the turnaround time, and as a part of continuous improvement activities to promote the business as well as manufacturing process. I hope the session is valuable, and thanks for your presence.
Thank you, Tamilvan and sir, for the wonderful session. I hope everyone enjoyed the session and it is informative. So once again, thank you all. Hope you all had a quality time. We'll leave for the day now. Thank you all.